Hello everyone, this is Shobit. Today I'm gonna be explaining about the Vertex AI, which is quick start. You guys might be not interested in this after listening the topic name from me, because we already have seen couple of videos on Vertex AI. So what is the new with this Vertex AI quick start? Okay, so basically I also felt the same while reading this. But as soon as I started deep diving into that, I felt love with this because of the real world problem we are taking and discussing here. Okay, so the problem is introduction, which is a customer lifetime value CLV prediction with BigQuery and TensorFlow on Vertex AI. So being in retail domain for so many years, I immediately fall in love with anything comes with respect to the customer and their data manipulations because that derive business strategies. So customer lifetime value is basically we are gonna be about to learn that how any business, whether it's small or a big enterprise, regardless, they look for the customer data, whether the customer is spending too much money for our services or products. Okay, so what are those products or services, how much money they are spending, whether they have a repetitive pattern or not, what are the customer they buy once and then not coming very frequently, so that we can prepare some kind of promotions or marketing strategies for those customer to take them come back. Okay, so in business we deal with two type of things. One is basically retaining the existing customer, and second is attracting the new customers. So both use case can be done with respect to the CLV, customer lifetime value. Okay. So what we are going to be do here, the learning objective of this exercise is train a TensorFlow model locally in a hosted Vertex notebook. Okay, when I said locally, so that means we are creating our own customized Python based notebook, and on top of that we are writing all the code. Although the code is not very much big, I'll show you step by step what the things are happening. But it is a very huge lab and I don't want to be running this video for so long, definitely. So I want to be try to summarize it. Okay. And you guys can come anytime on this video, and there is again it's a Google GitHub um, openly available code. You can come, you can take that, you can run your own. Okay, so first thing is training a TensorFlow model locally. Second thing is creating a managed tabular data set artifactory for experiment tracking. So tabular is gonna be is a visualization tool which will tell us how the trends are going, how the customer is behaving, all those things. The data insights we can take and make a informative decisions out of it. Third thing is containerizing your training code with Cloud Build and push it to Google Cloud Artifactory registry. Okay, so it's the basic thing. We are creating some images, the model we are building, and then pushing it to an Artifactory to use it. Run a Vertex AI custom training job with your custom model container. So we are going to be creating a training job here. Use Vertex TensorBoard to visualize model performance. So TensorBoard is basically again another open source provided by Google, or they have kind of donated it, just like TensorFlow. So, but here when we are saying Vertex TensorBoard, so it is um, GCP provided service. Okay, so that we don't need to set up anything. It is we can use the out of the box features, just like we used for GKE. Google Kubernetes engine, same way Vertex Tensor Board here. So not same way, but it is, I'm saying, in the concept of the GCP or cloud provided services. So in that tensor board, we are able to see the performance of our model, how it is doing better, how it can be do much more better by hyper tuning, or um, by using different neural networks, or what we can do better. Okay, so by watching that performance, we can optimize it. Then next thing is deploy your train model to a Vertex Online prediction endpoint for serving predictions. We have already done with other labs, previous videos. You can refer that one. I'll give a quick glance here as well. That by using one command, we can deploy that endpoint, and then we can start serving the predictions. And the last thing is request an online prediction and explanation and see the responses. Okay. So this is a high level Vertex AI, which is general available architecture. So if you see on the top, it is Auto ML, which is no code, low code workflow. So you can use vision, video, language, tables, forecast, BigQuery ML translation, all those kind of openly available um, APIs by Google, or it can be combined, clubbed in AutoML and put it in Vertex AI, so that rather than we write our custom code for train any model, we can utilize the AutoML directly. Okay, now next thing is custom training workflow. So if we are doing anything custom, so definitely we'll start with some experiment. That experiment includes regarding the data labeling, model building, model builder SDK, and TensorFlow board or Tensor board. Then after this experiment, we are gonna for training. In train, we are doing training, NAS, and Visor. So Visor is, or Vazir is, basically for hyper tuning. NAS, I don't have any idea. We'll see later on when I will get learning. I will share. The last thing will be deploy, which is predictions and matching engine. Okay, again we are using prediction, but matching engine, I don't know. We'll see later on. The next level came, or next layer came, is model monitoring. So monitoring, definitely we are now using tensor board to monitor things, or for seeing the performance. And then we will see if something more is there for the monitoring. And then explainable AI, it gives the inside information of our data or models. Then feature store, we have seen already in previous videos, which is helpful for creating a shareable data set, which where we put all the features, and then we do our exercises on those features on which model has been trained. Then we have ML metadata, for collecting all the metadatas which is required to run a model. And basically we are changing those metadatas based on the dynamic modeling we are doing, rather than the static one. Okay, then we have the next layer is pipeline, which is MLOps. We'll see. We are gonna be set in this lab as well. One pipeline, and then notebook, Jupyter notebook, where we are writing all the codes and running everything. Okay, so here it is mentioned what I meant with predictive CLV, how much monetary value existing customers will bring to the business in the future. Okay, and or a higher note, deciding which customer to target with advertising to increase revenue, or identifying which customer segment are most profitable and plan how to move customer from one segment to another. So we can, if customer is not buying this, we are offering this kind of that information. So here is the historical pattern of the customers. We can see on the timeline, how they are coming, they are spending more versus less, or what is the trend going on with the historical data for a given customer. Okay, the source of this diagram is from this cloud architecture center, and everything is again presented here as well. If somebody want to go through about the CLV prediction, you can go on this page. Google provided this, and then read all those things what I'm mentioning here. And they are telling a part 4 as well, which is using AutoML table, which is not covered as part of this lab. Okay, then we can derive couple of factors just like recency, frequency, monetary, all those things. Okay, so setup, I'm starting now how we are coding. So setting the lab, path, environment, project setup, bucket setup, all those things. Importing certain libraries. Important one is TensorFlow, by which we are doing most of the work, and then PyPlot to draw all the visualizations. Okay, and here we are using Vertex SDK for Python. Okay, so here AI platform is what GCP use for all the AI work, including Vertex, and initializing that AI platform with the project location and staging bucket. Then we are going to be downloading certain data set, which is online retail data set. Okay, from the UCI machine learning repository. Okay, which has 541K transactional of customer between 2010 Dec- 2010 December to 2011 December. Okay, 1 year for a UK based and registered non-store retailers. So moving forward, here we are doing the data ingestion in the BigQuery. Okay, so we are doing again certain steps to create the data set and table for the BigQuery. All those naming has been given. Here it is downloading the data and then gonna be put into the BigQuery. We are then doing data processing. In the previous videos you have seen that data in raw picture is not fit with the model. We need to refine the data first, validate the data, and make it workable for model to be trained. Okay, so with that, we are keeping few things here. Keep only records that have column ID, aggregate transaction by day from invoices. Keep only record that have positive order quantities and monetary values. Aggregate transactions by customer ID, and compute recency, frequency, monetary features. Okay, features here in the feature set we are defining customer country. Of course we said it's UK, so we are just gonna be handling UK data. Then we have number of purchases, average purchase size, average purchase revenue, what is the age of the customer, and day since the last purchase. And in the target we are checking the monetary value 3M. Okay, so here in the lab demonstration we are using DNN, predict customer 3 months ahead, CLV monetary value. Okay, so this is DNN is our deep neural network, that is we are going to be doing here. And then we are doing exploratory data analysis, EDA. And in that in the BigQuery we are running certain commands, and we can describe that what is the mean, standard, and 25th percent, max, all those values are coming. Okay, since the last purchase. Then we can see that historically, recency. So you can see there are certain customer which is dipped. Okay, so we might not need to look those customers. We might be need to focus our strategy with the high potentials, and a low segment with great advertisement, something like that. Okay, how often customers purchasing, again we are running that. Frequency, keeping up the min max and standard deviation. Writing is historically we can see how this chart come which is equal, less than or equal to two purchases. Okay, so there are, it seems this customer is basically wholesale customer which is buying so much quantities. Okay, how much are the customers spending for that? Here is the target monetary value 3M. and we can see the customer is ranging from 290 to 268k gbp. Okay, so by looking this, we can have different strategies to attract those customers. Establish a simple model performance baseline. So for BigQuery, we are, or even I should say, for custom TensorFlow DNN regressor model, we need to define certain baselines. So we are setting some baseline data here. Okay. After that has been created, next you should look at the plot, the baseline result to get a sense of opportunity area for ML model. So again, writing certain other queries, we are able to see this is the customer ID, this is the predictive monetary value 3m, this is the target monetary value 3m. So for this customer ID, this is predicted, but this is target, which is gone high. Same for this, it is gone low. So by that one, we can able to see what exactly with happening with the data. Okay, we can plot the actual versus predicted for customer 3 months monetary value, and we can see um, the data is scattered, which is going out of the way by this linear equation. So we can able to train a TensorFlow model locally. Here it is training, and then we are splitting the data for training that much record we took, for test that much, and for validating that much. Okay, then we are creating different spreadsheet model training. We are setting everything here. Data set has been defined. Tensor slicing we are doing on those labels, numeric features, um, those things. Then we have those training, training, testing, validation. All those data has been created. RMSC method has been, regression matrix has been applied on top of it. We are building the model here. Okay, once the model is built, then we are plotting that. Somehow that plotting not worked. I was trying, but due to the limitation time on this lab, I'm not able to set this one. Okay, then but other things are working. So let's move on. Here we are putting the tensor board callback. Okay, so we are trying to set the tensor board as well. We are putting a model fit here. By model fit, it was executing all those. It is executing the model and then making the prediction or epochs from 1 to 10. Okay, the values for RMSE, you can see it is keep changing. Value for MAE, MSC, or RMSE, all three models. Then you can check the loss and value loss uh, on the data frames, and then after executing those things, you can see the train result, dev result, test result here. Model prediction calculation plotting. Those plottings came here for customer 3M monetary value on the train data, dev data, and test data, which is means for train data you can see it was more out of the way, but for the dev it was nearby, and test is also be mostly nearby. So little bit here and there, whatsoever it is here and there, we can again uh, validate the data, tune it, and then rerun the model. Okay, then creating a managed tabular data set from the BigQuery data source. So here tabular data set we are creating. Okay, tabular data set again for the visualization purposes. Then we have Vertex AI custom ML model training workflow. So there are two ways basically for doing ML model training. Uh, One is for use a Google Cloud pre-built container. Another is use your own custom container image. So this one is the pre-built container with we need to run a task.py py, and it is already having training libraries such as TensorFlow or XGBoost. With the custom container image, we need to create a Docker file and then cloudbuild.yaml and then move that image to the artifactory, and then we will run our ML model or the pipe through the Vertex pipeline. Okay, so here is the containerize your model training code. This is basically the structure. Writing the model.py, putting all those details. Once it is done, task.py, Docker file, then we have the requirement.txt. We use Cloud Build to build and submit the container. Okay, so this will create artifactory repository for custom container images. It will push the image on cloud build. Okay, here we are setting all those parameters. Cloud build. We ran this cloud build. It took around more than 10 minutes to build that image, and then push to cloud build. Okay, success. Run a custom training job on Vertex AI. So create a Vertex TensorBoard instance for tracking your model experiment. So Vertex TensorFlow board is Google managed version of open source TensorBoard for ML experimental visualization. Okay, so we can do for these TensorBoard, it can help us in these ways, but we are setting up our AI TensorBoard and then run your custom container training job. As soon as we are going to be running this, um, it will it will tune the model. Okay, I saw certain problem because of this lab is not allowing me. The quota limitations was there. Okay, I have set it only two CPU here. Okay, two vCPU basically. So it might be ran out and it is not helping me to go beyond. Other than that, we can serve your model with Vertex AI prediction, online model predictions, and explanations. Build the explanation metadata parameters. So, explainable AI is there, which integrates feature attributes into Vertex AI. Vertex explainable AI helps you understand your model's output for classification and regression tasks. Vertex AI tells you how much each feature in the data continued to predicted result. You can use this information to verify that the model is behaving as expected, identify and mitigate bias in your model, and get ideas for ways to improve your model. Okay, so by saying that this is explainable AI, then we have deploy a vertex endpoint, which we did earlier as well. So here you can provide the endpoint details with model.deploy, and then it will create an endpoint for us, get an online production serving. So we are putting some test instances here. We are calling endpoint.predict, and it will give the predictions out of it. We can put endpoint dot explain, which will do explanation AI, and then um, based on the feature attribute for prediction, your model has learned that average purchase revenue and customer age had the largest marginal contribution in predicting the customer monetary value over the 3 months test period. So this is what the things can give the better idea of our problem for with the um, customer journey, and it will helpful for us to grow our business, target the particular audience in different ways. Hope you like this video. Have a good day. See you soon.